Hey, this is Sam from Shure. In this video tutorial, I want to talk about frequency statuses in the coordination workspace. The frequency coordination tools in Wireless Workbench have a lot of different features, and the spirit of them all is to collect as much spectrum information as possible and to try to find compatible frequencies for all of the solutions as a part of your wireless rig. Now, frequency coordination, for those who operate at a professional level or are working with a lot of RF congestion in their area, is an iterative process. Seldom do you press coordinate once and get all the frequencies you want and you're good and ready to go. So because of that, we wanted to make sure the tools in Wireless Workbench were descriptive enough to show you the frequencies that you've asked for versus the frequencies the calculator finds every time you run a coordination. And I'm going to break down some of the UI elements we've used to display that for you in this particular video. Let me explain my setup here really quickly. I've got 16 frequencies of Axient in the G1 band, and you'll notice in my coordination workspace I've just blocked off all of the spectrum, all of my DTV stations except for one channel. And this is just to simulate what it would be like to coordinate frequencies and be asking for more than you're able to find, and you'll see why those status elements are important in just a second here. So the first thing I want to talk about is the color that we show over here in this frequency row right here. Right now you'll see all these things are yellow. Apologies to my colorblind friends out there. What yellow means is that this is just a raw frequency request that has been unfulfilled. And when I say request, I mean because this row is here, we are asking the calculator to find a frequency for us. Now the reason this says find best and not some other frequency value is because we added this frequency virtually. There was never a value to start with. And this value informs the calculator, hey, when you go and calculate frequencies, make sure you find a frequency for me. So when I press calculate, you'll notice from yellow, all of these frequencies will turn a different color. Now, I asked for 16 frequencies and only found 12. So the 12 frequencies that I found are shown with a green background to signify that the request has been fulfilled. I didn't find 4 of the 16 frequencies I asked for, and those are colored red to say, hey, these requests were unfulfilled. So you'll notice that we use these colors to signify whether or not a frequency request has been fulfilled. The only other parameter in all this that I want to mention is this lock control. And this lock control allows users to lock down certain frequency values, whether or not they were manually entered or coordinated. Locking a frequency down tells the calculator to make sure this frequency stays put and doesn't change the next time we coordinate. And you could do this for a number of reasons. But when I calculate again, you'll see those 2 frequencies I locked down, they stay transparent. They've lost their green color because they are not requests that have been fulfilled. They are merely frequency constraints, you can think of them, that the calculator is now working around. Still, my requests that were fulfilled are green, and those that were not fulfilled are red. Now, all of this I wanted to explain to you independently from analysis results, or basically how compatible a frequency is. They are separate things. This is indicative of the compatibility of a particular frequency, which is to say whether or not the frequencies of, in this case, Axient G1 are respected with all their channel and intermod spacings, and they aren't being violated by any spectrum environmental things we've specified in Workbench. That's different than whether the frequency request has been fulfilled. You can see if I were to change one of these frequencies to something outside of this little sliver, if I set it to 496, everything goes to unanalyzed because I've changed something, and we would need to reanalyze these frequencies to tell whether or not they are compatible. But if I analyze these, what analyze will do is it'll check the compatibility without changing any frequencies. You'll notice not only is this frequency incompatible because I parked it on top of what Workbench thinks is a DTV station, but it's also had other implications on frequencies that were previously compatible. So what I want to show you here is that analysis results, whether something is compatible or not, is different, independent from the fulfilled status of each frequency request. Now I know this is a little bit complicated, and iterative frequency coordination can have a lot of different steps and facets. Shure's goal was to build a robust and versatile set of tools that allow you to iteratively find frequencies for complex RF environments. And that's why we built these tools the way they are. So I hope this tutorial was helpful. I know we covered some varied topics here that are a little bit complex. If you've got questions or have comments or want to see different aspects of this feature or feature set explained in more detail, please be sure to leave a comment down below. Thanks.